Good morning. Hiya. Hope you're okay. Bit of decent weather last week, wasn't there? So hopefully you've also settled into going into school, those that are, and have just got into a little bit of routine. So at the moment we are doing lots of things to do with weather and climate. And what I want to do is to sort of use this word interleaving or revision. And what I want to revise is the concepts of hurricanes, tropical storms, willy willies, or typhoons, whichever phrase you want to use. So there are 13 slides in this, but there's only a few of them actually ask you to do anything. And when we get down to the 11th and 12th and 13th, then you realise there's a little bit more than just flicking through them, me talking to you, and you sort of reading. So realistically, what we're going to do is we're going to try to be able to describe where hurricanes are going to occur, where they're going to come from. What are those conditions, like a recipe that's needed for them to form? And then for you to be able to go through a process which includes the plenary at the end about the step-by-step process. Now, if you want to, you can be in on the Tuesday session at 10 o'clock. If you've missed that, then of course you can use this, or you can email me and I can then include you in Teams. So there are lots of different ways of going about doing this. So I will also be using this, or have used this in Teams, depending on what part of the week you're in. So here we go. So the first stage is to look at the basic task. Okay, now you can see two photographs. One's a very, very much an aerial view, isn't it? It's almost a satellite view of a massive, great big weather system, and that's the one that's on the left hand side. Okay, so you can see the formation, you can see the circling around the particular formation, which is the eye, and then you can see in the photograph the impact of what it's going to be like. Okay, now what I want you to do is to summarize each slide. So under the title of Hurricanes, the recipe or the formation, all I want you to do is to summarize each slide into no more than 10 words. Okay, and it's just to try and get you to think of the language that goes with hurricanes, typhoons, etc., etc. Okay, so if you go on to the next one, I'm going to pretend that you are going on a holiday. So I've created this one for you, and you're going to Florida. I wish we could, but I think lockdown has sort of scuppered that, because in theory we can get there, but then we've got to spend 2 weeks at home and be quarantined. Well, that's not going to happen, is it? Okay, so on your first sheet, draw pictures or diagrams, use schemata, whatever you fancy. You're going on a holiday, so you're going on a plane, you're going on a holiday, so the sunshine and it's tropical, or it's a palm tree, and maybe even Mickey Mouse and representing Florida. Be realistic, it might even be a couple of lemonades, mightn't it? Okay, so little schemata, little things that make you think, okay, what is it about this zone that's going to sort of make it a potential for a hurricane? So when you're up on this slide, so you're on slide 4, people have come here for this warm tropical seas. So obviously there's going to be language there that you're going to be using. There's high temperatures, there's sunshine, which is guaranteed, and that in turn then has an impact of creating conditions under which hurricane's going to form. So there's that photograph, slightly different this time. This one, it's not quite as intense, but it gives you a better satellite image, doesn't it? Okay, so really truthfully, it's towards the end of the Northern Hemisphere's summer that we see the hurricanes really forming. And they've formed from several tropical storms, which may or may not join together. If they don't join together, it's unlikely that one particular storm is going to be sufficient. It's normally several being drawn in together, and that drawing in together of the evaporated water from the very warm seas, that's actually going to cause the process to happen. Now in the next slide we've got a diagram. Now the diagram itself tries to show you the fact is that this is a vortex, and it forms an eye wall around it, and these dense cirrus overcast clouds then start to form, and then they start to create these rain bands, the rain bands that are going to be very, very typical. Now, as the intensity grows, that's when the circling motion. Now, can any of you actually remember whose name it is that actually brings in the effect of the movement? Do you remember the term Coriolis? Okay, the Coriolis effect. Well, without the Coriolis effect, there's nothing going to happen, as a tropical storm is just going to stay a tropical storm. It's not going to become a hurricane. You're not going to get that intensity. If you can imagine a skier swirling around, well, a skier's not going to get anything. It's only when a skater starts to twirl with their arms, then you start to get a different formation. So there's a bit of a difference, and that's what I tried to say, the difference between a skier who's just sort of making their way and going up and down and turning and twisting and that sort of stuff. But the skater actually uses their arms, and those arms then increase that intensity like the Coriolis effect. So there you go with your picture. I've just shown you can drag and drop it, make it bigger, and if that helps you, brilliant, do it. Okay. A lot of rain, a lot of wind. Now those are two. Those are two particular factors, aren't they? So in this slide, you can see in the description, it's the same as the first picture that you had up in the second slide. And wind force of 140 miles an hour. Okay, so that's more than double anything that Preston's ever had. The towering. So we've used these terms now for different cloud formations. This one's cumulonimbus. They're dark, they're dirty, and they're heavy. They are 4,000 meters high. That's 4 kilometers high or higher, sometimes as high as 8 kilometers high. So notice that language there, torrential rain. So that's the kind of term that we'll be expecting you to try and kick in with and be able to use on a regular basis when describing the difference between a serious rainfall and a torrential rainfall. 15 centimetres an hour, that's 6 inches in old money. That is a lot of rain. That's going to fill a bucket in an hour and a half to 2 hours, and that's over every little piece of land. Let's say you're looking outside of your window now, you look out and you go, okay, so what does 6 inches, what does 15 centimetres of rainfall actually mean? Well, it means that you would, if you went outside, forgiven the wind, but if you went out just in the rainfall, it would be up to your calf. It would be in 2 hours somewhere near your knee. So then imagine you're on a hillside or you are close to the coast. Now, what's the third factor? It is the storm surge. So when you think about the storm surge and the rising strength of each of the storms, then that will become into more detail later. So there you are. We've got our pattern. Remember what this term is? Linear. Obviously, it's in a line, isn't it? Notice that they're not exactly on the equator. They're about 5 degrees to 20 degrees north and about 5 degrees to about 18, 20 degrees south. Now you can see that they are intense. The intensity of them varies depending where they are across. So, and if you go here over on the western coast of Africa, nothing. But as you go further in towards the Panhandle, remember where the Panhandle is? That's Florida, and that's into the coast of the Bay of Mexico. Okay, so that's South America, North America, there's Florida, the Caribbean's here. So on this side, this is the Philippines, Japan, and then obviously you've got across this little group of islands there, and then you've got your Thailand, etc., etc. Notice the little group of typhoons that impact mainly on the east coast of India and, of course, up into Bangladesh. Now, as you go across the top part of Australia, you'll notice that realistically it only really impacts on the east coast and the northwestern coast. It never hits down the south. Why? It's too cold. The water down this side, the islands of New Zealand, only ever the Northern Island gets any impact on it. Go down the whole of South America. It just doesn't receive any. Why? Because the water down here is simply too cold. Now go to ourselves and we're here. There's the British Isles. Yes, we get the Gulf Stream, which just about keeps us maritime, but what we don't get, and let's be realistic, anything above 50, 60 mile an hour winds. Our buses really wouldn't cope, would they? So, on this slide, all I want you to do is to think about where they're going to lose energy. Where are they going to lose energy? Well, they rely on the heat and the moisture, the critical temperature that we've talked about, and you've already seen it as being 27 degrees or higher, 27 degrees centigrade or higher. Okay? So, as they pass over land, they lose that moisture. Because obviously the land, all right, you might have a river or you might even have a big lake, but the reality is there just isn't the actual huge quantity of material by way of energy that's going to come up through the land and actually impact on the actual hurricane system. And very soon they drop from a scale 5, remember the scale? Yeah, Saffir-Simpson scale. That Saffir-Simpson scale runs from 1 through to 5, with 5 being the most extreme. Well, even the most extreme, if they spend an hour and a half to 2 hours over land, they've dropped to a 4. By the time they've done 4 hours, there may well be a 3. So, I want you to be able to repeat back information. Okay, so in this slide, it's just lining up. So you need to flick back when you are going to rewriting me some information as part of your plenary. Okay, so there's 7 points that you want to make, and you really need to think about them being a step-by-step process, a bit like a recipe. When we discuss it live, which we would be doing if you're on the Teams discussion, we'd be looking at adjectives, we'll be looking at the language to describe hurricanes, and we're trying to use higher level. And I gave you an example before of torrential, didn't I? Okay, but there are common geographical terms used for the formation process, and you need to know them. Okay. Now, I've given you a piece of work here, and I really want you to go to town. And in English, you already use alliteration, you already use different language processes to actually make your piece of work sound better. Well, the reality is, I'm going to ask you to do something similar. I want you to get used to, instead of pigeonholing and keeping all those wonderful English skills alive just in English, I want them to come out in some geography work that you're going to do. So on this piece, I'm going to ask you to write a plenary. Okay, so it's an email to me, and it's you to write a short email. It's a postcard type thing describing how you saw on a Florida holiday as Hurricane Waters arrived, it destroyed and then departed from your wonderful Disney holiday of a lifetime. Now, if you think back, what have you got to say? You've got to go back to the slide and think, okay, where were we? What were we doing there? Why is the hurricane a danger there? Yes, it's flat. Yes, it's very warm for a large period of the time. And you arrived on your holiday in the traditional school holiday period. And that in time has caused you a bit of a problem, hasn't it? Okay, so I've spoken a lot. And all I want you to do is to go through the slides, work your way through them. And as you go through them, spend your time trying to keep it to 10 words for each of these. Go back to the diagram. Yes, play with it. Yes, make it bigger. Go back to the linear lines of the satellite photograph showing where intensity is, and then produce me an 8 marker. Okay, so I would like that sending to me by email by a week on Sunday. Okay, so I'm giving you 2 weeks to have done that, because I will be asking you to do other things as well. Okay. There is a worksheet that goes with this, and you'll be able to see it when you go into Doddle.